Jim Davis here for another installment of Questions for the TAC. The Fluke Technical Assistance Center, and every once in a while gets questions. We appreciate the questions, and some of them are probably being asked by a lot of people. Today's question is, what is new in the TIA 568 standard? Yes, the TIA 568 standard, now this is specifically ANSI TIA 568.2 copper components, has now come out with an E-revision. Oh no, what's it going to do? Nothing too dramatic, but something that I think you're going to find very useful. Today, why do people run copper? Because they need to power things. We have power over Ethernet. That's why copper is going to be around for a while. So there is a parameter that is specific to the performance of power over Ethernet that we want to make sure the cable is able to support. These are measurements of loop resistance, resistance unbalance, and pair-to-pair resistance unbalance. We'll go into detail on those another day, another story. Let's be quick. Now, because we have changed the component standard, it doesn't mean we need to change the tester standard. The tester standard is, of course, the TIA 1152, which is still on the A revision, but we've made an update in the current 6.13 firmware for Versiv, taking into account this adjustment for the resistance measurements. So I've got an interesting piece of cable here, and we're just going to run a test on this piece of cable. You'll see that we're getting ready to run a standard. This is a TIA 1152 compliant category 5E test. We will push test to start, and there we go. Now, I've rehearsed this, and every time I rehearse it, it passes. So we'll see if it passes now. Hey, it does. Wonderful. Look at that. We're passing. We can go into the parameters, and for years and years, we've gotten this question, why is there a letter I for resistance? Well, the 1152 standard, the standard for field testers, does not require that we run a loop resistance test. We can drill in here and see that it is showing us the values, but the limit is not applicable because there is not a field limit. So I mentioned that the standard has changed, and the change in the standard, in the component standard, is to give us values and to tell us that in the factory, when they're designing, when they're building these links, they need to test. We've made a small change to Versiv. Hey, let's save this test result. Why not? We've made a small change to Versiv where the new default limit, I'm going to change my test limit here, and what we've done is we've selected the plus PoE limits. We have three types of tests in the tester for standard 5E, 6, and 6A. We have the basic standards compliant limit. Today we're testing 5E, so the 5E permanent link, and we have an enhanced category 5E plus PoE. Now this plus PoE suffix on the test limit adds the tests that are specific to power over Ethernet. Loop resistance, resistance unbalance, and pair-to-pair unbalance. I'm testing the same cable. I haven't unplugged it. I showed you the values, and we're generating diagnostics. Why would that be? Well, something's wrong with the cable. Again, we just saw this pass category 5E with no problems, but now we're failing. And when we go into the performance info, because we've added these loop resistance tests, we don't have a letter I, and we're failing. And let's look at that. The measured values are the same. We just didn't have a limit. Now that we have a limit, we see that this cable is exceeding the requirements for loop resistance. It happens to be a copper-coated aluminum cable. But to appreciate the change in the standard, the new definition of what the limits should be for loop resistance, we've updated the tester, and we'll find now, let's just go in and add a new test. The change that we've made for the tester is the default test is now going to use those plus PoE limits. Do you have to use plus PoE? No. But because you're probably going to be running power over that cable, we wanted to make things easier for you. Now we still have another fancier test, and that would be the plus all test. The plus all test tests parameters that are not required, that are not specified for field testing, like TCL, the balance tests, and some other exotic tests that we can do. Do we need to run that test every day? Hopefully not, but we have the plus all tests if we've got a failure. If we've got a complex failure, we really want to look carefully at the cable, we could do that. But for today, and I think we've been talking about this for a couple years, you probably want to use the plus PoE limits to make sure that your cabling will support power over Ethernet. Hey, there are a couple of other new updates in the tester. Let's walk through that again, this is in the 6.13 version. We're going to create our extended reach limit here by putting together a couple of different pieces of cable. You have a device that's more than 100 meters away, more than 90 meters from the closet, plus 10 meters for patch cords. Somebody said I have a sensor on the roof. The sensor on the roof tells me if the fan is running. How do I get up there? Well, the way to get up there is to put in another telco room. That's what the standard says. We want to follow the guidance of the standard. Following the guidance of the standard has worked well for us up until now. If we follow the guidance of the standard, not only will everything work today, new products that come out tomorrow will work on the same cabling. Jim, I need to go farther and I cannot afford, or it's not worth it to me to install a telco room. Telco rooms are a little bit expensive. You got a room, you got a door, you got a lock, you got to have a smoke detector, you've got to have a sprinkler head in it, et cetera, and you can't use that real estate for something else. So that could be expensive. What other alternatives do we have? Well, you might consider using powered fiber. Fiber goes a longer distance. You can use an oversized conductor to supply either PoE or the fancy new Class 4 digital fault-tolerant power or digital electricity to run power out to those longer distances. And you'd still be standards compliant and NEC compliant. Another way to go would be to use a proprietary extender device, something that puts more power, something that is not PoE standards compliant. That might work great for today, but again, we've got that problem with tomorrow. Final option I'm going to talk about is an engineered link. You might work with your cable supplier, and these are brand X cables, and no, we're not going to call anyone out here, and there's two of them, so I'm really not working with any one brand. But the idea here is I have a specific application. I have a specific camera. It's sending me a specific amount of information. I'm probably not transmitting full, uncompressed 4K images from the camera in the parking lot. It's probably a lot less, and I may not need a full 90 watts of power for this camera. So I can work with my cabling and connectivity manufacturer to say, for this specific application, do you have a cable that will support that extended distance? And we'll work together and they will support that extended distance. Now let's take a look at what some of the challenges are when we go beyond 100 meters. Now I'm just gonna go back here and let's stick with that same category 5E test that we passed before, and I'll push test and we'll run our standard category 5E test. Now this is probably going to fail for a couple reasons. I might have a next or a return loss issue. But generally, what are the limits? What are the parameters that are affected by us going more than 100 meters? What do we measure? We measure signal and noise. The signal is certainly affected by going farther distances. If I move away from the microphone, my voice is going to go down. Same thing, as the cable gets longer, we're going to have more signal loss. Now, the noise parameters like near-end crosstalk and return loss are less impacted. So let's take a look at what failed on our test result here. I haven't looked yet, but I'm sure something did fail. Hey, look at that. We failed, big surprise here, length. I have 135 meters of cable, doing a permanent link test. I've got a 90 meter limit. I failed the length. Could it be an NVP issue? Maybe, but regardless of the NVP, I've also failed propagation delay. Propagation delay is the amount of time that it takes to go from one end of the cable to the other. I can't get around that. Even if I use an oversized conductor, I'm going to fail propagation delay when my cables get too long. The other parameter that I mentioned that we're going to fail is the signal strength. You see that we failed insertion loss here. We'll look at this more closely in a moment. Yeah, we'll look at it more closely right now. Here is our red limit line, and the limit line is decibels versus frequency. As the frequency gets higher, we have more insertion loss. So these are the parameters that we're going to need to update when we work with our manufacturer, because we can work with the manufacturer and they can say, for this application, here is the cable that we recommend, and here is the distance that you are able to cover. So Let's dive into our different test limits, and we could pick any one of these, but this is one of the manufacturers. In fairness, there are many different manufacturers who are out there who have many different limits, and you need to work with a specific manufacturer for that limit. Some of the manufacturers will have more than one limit. They'll have a 150 meter limit, a 200 meter limit, a 250 meter limit. Typically, as you go longer distances, you get less power and you're going to get a lower speed. If you only need to go 10 megabits, you can probably go farther. So let's push test. We'll get a trusty error message here. It's trying to help out. It says, hey, this is a channel test, but we're going to use our permanent link adapter. Because what I'm really interested in showing you here is how we have adapted the limits to compensate for the propagation delay. It takes longer to go from one end to the other end of the cable. And we almost passed. Star pass. Again, this is not any specific manufacturer's cable. This is just some cables I had sitting around so we could go more than 100 meters. So what parameters have they changed? Well, in this case, in this specific example, they don't have a length limit like the ISO 11801 standard, but they do have a propagation delay limit, and the propagation delay limit contemplates us going a longer distance. The other thing that's going to be affected is our insertion loss or our signal strength. And remember before, when we looked carefully, we saw that the red limit line, let me move this cursor out of the way, the red limit line was below the measured values. So manufacturers will come to us and they will provide us with the limits for their product. And they will say, here is the formula for the curve for next, for return loss. Here is the curve for insertion loss. And here's the frequency limit. We know that as the frequency goes up, we get additional return loss, but 10 megabit Ethernet does not need 500 megahertz of frequency. So they'll say, hey, here is a limit line that typically goes to a lower frequency. It's higher up, so we're able to pass the insertion loss. So if you're going to use one of these extended limits, remember my personal feeling, I'll get on my soapbox for a minute, follow the standard, install another telco room, or use fiber. But it's not my budget and it's not my application. So if you are going to go farther than 100 meters, work with your manufacturer to make sure you have the right product, the right cable, the right connectors, and you can create an engineered limit for that specific application. There's not a guarantee that it's going to work tomorrow when they come out with a better, stronger, faster camera to put in your parking lot, but it'll work for what you're trying to get done today. All right, just a couple more things to show real quickly in the update and the standards. And I'm really excited about this one because it's based on the feedback that we're getting, the questions that you're asking us. And people have said, boy, it would be helpful if I knew as soon as I turned on a tester whether or not it was within its calibration period. So now, with the new 613 firmware, we're going to be able to tell right away as we boot up the tester whether or not it's in the calibration period. So here, what we're able to see is that this tester is within, 20 some odd days of its calibration period expiring. Oh boy, I better call up and get a scheduled calibration with my service center so that we're going to be okay. Now, this is going to count down from 30 days out until we exceed the calibration period. And now for this tester that was all nicely focused with the camera, we'll turn that one on and see the message that we get after the calibration period has been exceeded. There, of course it's there. I knew it was going to come up. So here we've got the warning message, hey, your tester is outside of the calibration period. From my perspective, if a measurement is being made, I want the measurement to be made accurately. If I'm at the grocery store and they're weighing my fruits and vegetables, I want an accurate measurement for that. If I'm installing my cabling, I want the most accurate measurement possible. That's why we'd like to keep our tester within its calibration period. If the cable's broken and I want to know the distance to where the cable's broken, calibration's probably less important for me. Okay, we've covered a bunch of subjects here. The new TIA 568.2 E-revision of the standard now defines values for loop resistance, resistance unbalance, and we've seen how we've put the new default test limit in the tester, our plus PoE values. We saw, and frankly, this cable scares me. This copper-coated aluminum cable passed the standard category 5E test limits. It was only by using the plus PoE values that we saw that it has too much resistance. PoE isn't going to run as efficiently on that. We saw our extended reach limits from many different manufacturers, and we saw this useful warning message that the calibration is expiring. All right, Jim Davis with questions from the TAC. Thank you for watching.